Hello and welcome to another episode of Throttle Stop Garage. In today's episode, we're going to have a look at the process that we're going to have to go through to get hood hinges to work on our project car. Stay tuned. Alright, so we're hitting that stage in the project where we're starting to get the little details cleaned up. I still have big pieces left to do, don't worry. This car is nowhere near being built. But as I'm cleaning up all the stupid little projects that are going to actually delay you being able to drive your car, we're going to get going on hood hinges. So in a prior episode, actually in a prior part of the series, we built the whole front end of this car out of carbon fiber. As a result of making that part out of carbon fiber, the hood hinges with the massive springs that were on here were never going to work. They were way too powerful for the hood. In fact, I could barely get them to close up enough in order to get the hood bolted on, and I thought I'd destroy the part if I tried to shut them. So we're going to have to get the springs dialed down, just like we did with the trunk, and in the doing, we're going to find out just how much fun this can be. Okay, so after a couple of days of playing around with this, I think you can start to see what the problem is, which is every time I hit the hinge with a little bit more penetrating oil, a little bit more rust comes out, just every single time. I've already cleaned this probably 6 or 7 times, and I still get more. So my formerly tight hinges were only tight because there was rust in them. Now they're not excessively loose, but they're loose to a point where we might as well do something different with these and get these fixed up. All right, so I'll show you what we're going to do with that here now. So if you watch the video, it'll be up here on the trunk hinges. They were just a simple hinge, right? Just one pivoting mechanism that I had to apply a force to, no big deal. These hood hinges, though, this is hilarious to me because I thought, well, this isn't going to be all that bad. So then I look online for how to figure out, this is called a 6-bar link. 1, 2, 3, 4, 5, and then that's the 6th link. So it's got 7 pivot points, right? So 7 pivot points, 6 links, and the most common thing I can find for how to solve this problem of how much spring would be needed to push to get this thing to open, the most common thing I find is that even the engineering students cheat to figure this out. So the cheating websites are the first things that come up. Okay, so I'm not going to be able to work this out myself. So here's what I'm going to do, because I don't actually have to work out the links. I have the linkage. I don't care about that part. All I need to know, dog bark, all I need to know is, in essence, how much mass, if placed on the link. So if I took a known mass, placed it where, say, the hood bolts on in this case, how much force does that take? As the doggo comes in to say hello. Say hello, Guinness. That's who you always hear barking in the background. I get it. Yeah, good boy. Okay. You'll boot the camera for Dad. Thank you. Okay. So, back we go. So this is where I'd like to place the gas spring. So I'd like to place the gas spring down here. And we're going to build a bracket out here somewhere. And when we get this done, all I need to do is be able to measure the force here. So all I'm going to do is take a clamp. I'm going to attach it to that point there. We're going to take the known mass here, right? And we've got our Amazon Fancy Pants scale. Okay, so I'll just I'm going to switch over to video lapse here. We'll just get this done. And we'll come back and talk to you once I get it figured out. It's set up on my welding table with a spacer jig so I can get things close. And then I found that the strain gauge that I'm using here, so the scale that I'm using is just I expect it's just an S-shaped strain gauge inside here. And what I was doing before was I was measuring it twisted like this. So I'm going to leave that video in just to show you don't do that. Because if I just pull straight on it, so I've reorganized things here so that I can get this to just pull straight down in a line from top to bottom. It's fine. So all I've done is zeroed. So all I've done is turn the scale on here, zero it, and then I'm interested in what this is for weight just off the down position, right? Because that's what it has to do. This is the number I keep coming up with, not the one that I just got. God, I don't know. This is driving me crazy. I get around 7 kilos here. So that's a ratio of 1.75. So whatever I have here, this pivot is seeing 1.75 times that mass. So I think with that little bit of knowledge, we can go ahead and finish off what we need to do for this. This spring's got enough stroke. So I'll attach the spring, weld the plate onto the back, right? And then just get this into the car, make the two, get it into the car, test it. If it comes flying up, that's too much. If it doesn't come up at all, that's not enough. If it comes up nicely, then my guesstimate garage engineering would have worked. So we're going to take that as a win. All right, so let's just get this done, and this shouldn't be this hard. And in truth, it wasn't all that bad, but I had to get the plate put in. So I've got the little plate here, just drilling and tapping the holes. I'm not doing this accurately. This is a prototype. This is get it in, get it done, make sure it works. So, you know, as long as it's kind of halfway decent, I'm fine. So out comes the squirt gun. We weld it all up, get both done. You know, it actually felt really good. I got to say, it felt really good to just blast something in and not really care. I spend a lot of time on this car caring how it looks and making sure it's perfect. And I mean, that's my own personal torture. But this was fun. There, hey, that works. Then we get it in the car. I tested the strength of the spring. You know what? Pretty close. Okay, now it's time to get the hinge measured up. Again, we've got a lot of these pivot points that are getting a little bit sloppy and a little worn out. So it's really no big deal to get this done and sent off to Send Cut Send for the cut parts, because it's all straight linkages, right? So we can get that fixed. We know what we have to do here, right, in terms of making it longer to accommodate the gas spring. And you can also see on this particular set of springs that are hinges that I am always at the end of my adjustment up. So the hinge actually wants to go down. Both hinges are like this, just the way the car is. So we're going to take these slots when I draw them in CAD, I'm going to just shift them up 1 millimeter or 2. And that means at the back, I'm going to run out of distance. So I am going to, when I'm designing this part, I'm just going to drop this down a few millimeters so I have enough adjustment. But first, I need to pull an angle from this. So it's not 90 degrees. It's not a problem either. It's just difficult to measure. So what I'm going to do is, again, just take a clamp. I'm going to take my Machinist 1, 2, 3 blocks. It's so useful and so cheap. Buy yourself a set if you haven't. I use them constantly in the garage. Can't get my clamp to work today for some reason. Okay, I just snug it up a little bit and take a square, and I'm going to square that. There, square, tighten it, because when I take the angle, if I'm not square, when I take the angle, and all I'm doing here is using my angle finder from my combination square set. This one happens to be a stair. Buy good tools. It's worth it. So then I've got a square reference face to set this to. Now I know it's not quite 90 degrees, so I can take it in. Get this back up to the stop. Take it in, and then I'm just going to carefully, holding it square to that face, roll it around the corner, and then I'll I'm going to check both hinges. I'm sure they'll be the same. This car actually is pretty good that way. Tighten it down. And I'm going to find what the angle is. In this case, I need about 12.5 degrees less than 90 in order to make this work. So that's good. Simple enough to do. But if I wasn't square to this face, then again, I could be at some odd angle to the whole mess and end up with an angle that I don't want. Now, Send Cut Send can bend these things into any angle I like, so that's not going to be a problem. And we'll get that done up. The rest of it's just measurement of links, which isn't really exciting. So I'm going to quickly measure this hinge up, take it into Fusion 360, drop the parts, lose the features that I needed for the old springs, right? So this is going to get cut and tossed. I don't need those mount points. Shift these up a little bit and square that back edge off. This is only going to take me just a little while to do. And then Send Cut Send will send me the parts, and we'll come back when we have the parts. And we're finally ready to start unpacking the parts from Send Cut Send. So we've got the bottom brackets, so those have to get welded together, so we'll do those first. And then all of the linkages to get this done. And I've got all the other bits and pieces arrayed already, so I've got all of my bushings, all of my shoulder bolts, all of the everything else that I need to do this is all ready to go. And so let's... I guess there's no time like now. We'll clean off the bench here a little bit and we'll get going.
So what I'm going to need is a little standoff at the front end of each one of those base brackets in order to hold the gas spring. So I need to hold the spring away from the hinge so that it can operate properly. So there I've just welded some nuts on the insides of some round tube that I've cleaned up, and that's going to work just about perfectly for that standoff. This is just a little nut plate that I'm making for inside the car. Again, I've added another set of mounts. So the original hinge only had 4 bolts holding it in. I'm adding an extra bolt whole location just to keep everything tied down. And top tip, if you're going to use a stainless steel fastener or any fastener to center your nut, just tack it and then take the fastener out and then weld it. All right, so no time like the present to get these base brackets welded up. So I'm just clamping them together with some bolts and a little C-clamp at the front. And then just a couple of TIG tacks is all that's really needed here, and these are good to go. They should never move, really, in their position, and that's all I had to do to them, folks. They were perfect right out of the box. So on the one half of that bracket, I've left holes so that I can go in and just button weld each one of these brackets together after they've been TIG tacked. Just takes a second. And remember, if you want to get a really good button weld, hit it with one material thickness setting higher than the material that you're welding. I know it's a little bit confusing, but so this is 1/8 material, so I welded that at the same settings that I normally would weld in a flat position 3/16.
Okay, with the sides all welded up now, I could have just left the dimples and made it look like I resistance welded it, but I didn't, so I don't care. So I wanted that to be reasonably nice and smooth. The other side will just take 2 seconds worth of buffing to get that fixed up. So that's nice and clean, but here's the problem. I think you may be able to see it. I didn't see it until I literally was looking at it. This is me, not anyone else. That hole's the right separation apart. This one's too close to the inside, so I have to move these out. It's like 3 mil difference. I have no idea what I did, but oops. Okay, so God, I could contact Send Cut Send and get them to make me another set that are right, but for the time it'll take for me to do this, I'm just gonna lay it out give myself the exact same that I need all the way along the edge. And hey, we make mistakes. I can't believe it when I do it like this, though. I mean, I work so hard at this stuff and I still screw it up. Anyway, I do what I can. So I'm going to get that laid out, and away we go. All right, now you can see we've got the holes fixed. They're now in the correct location. So I've just welded up that backside, as you saw, and then I've gone ahead and done all of the machine work to get those slots back to where they're supposed to be. I think that's pretty all right. Only you and I will ever know that that happened. Anyway, so now it's time to drill out the holes. So this hole gets threaded here at the front, and the other two holes get bushings installed. So we're just going to sort of ream those out because they're already to size. So just going to check and make sure that there's nothing left over from the laser cutting. And then we're going to go. And one more, just wanted to mention, I didn't do anything to these. So this is straight from Sencut Sen, just if you're wondering. Like totally, I said 90 degrees. They completely nailed 90 degrees. That's absolutely tight. I didn't clamp it, didn't have to do anything to it. It was perfect. So if you specify an angle, I guess their CNC machines work. All right, let's get to work. So a little while later and we're done. So all I've done is just metal finished these. That's nothing special really. It's just deburring, making sure everything's neat and tidy. Again, the welding went well. Stops up here on the back, and now time to unpack the rest of the treasures and do the same, right? So we'll just get the edges knocked off of these, get them touched up, and then we should be ready to go for assembly.
Let's take a moment and talk about friction. So these parts had rusted out in the bushing area before because there wasn't one. It was steel on steel. So I didn't redesign them to work that way. I went to McMaster Carr. I found myself a flanged bushing, but the flange wasn't really wide enough to handle what I thought would be the full lateral load. And it was a little bit too long, and that's going to work out okay. So I got two different washers, one that fits over the hat, the top hat part of that flange bushing, and the other one that goes perfectly on the bushing on the other side. And I snap it all together, and I've got a really nice 3-part bushing that's going to do the load perfectly. Now, I could have done it with just a straight through radial bushing and 2 of the same on either side. That probably would have been easier, but it worked out.
Okay, so just a little bit of mucking around, and now we are there. Okay, so that's perfect. All these joints are nice and tight. Shoulder bolts in. The thrust washers as well as the bushing on the inside. So those should give lots of service. Plus they're fully rebuildable. If I ever need another set, I'll just rebuild these. Okay, so now we're going to grab the powder coat oven, get all this stuff powdered up, and then we're done. Okay, so we're out of the oven and we're all cooled, and the parts have gone through their cycle, so they're now a lovely gold color, as you can see. But any oils or any other crud that's in there has now been cooked off, and we're ready to blast these parts clean and then get them powder coated.
If you've watched my previous videos where I've had a little bit of fun with my old Eastwood powder coat system trying to control the air pressure, you'll notice that I'm starting to get that air pressure dialed in, but it's because I've got a brand new powder coat system. And boy, that makes a big difference in being able to have that level of control.
Okay, so hot out of the oven. Well, hot in the oven. That looks fantastic, folks. Really, really happy with that. They're perfect. And this is the new powder system. So this was sent to me by a viewer. So thanks, Don. Thanks very much for this. It was sitting in his garage, not being used. So he thought I could make some use of it. Put it together. That is quite a bit different from the Eastwood gun in terms of the control. So you've got both a feed air and an auxiliary air. And once I got that dialed in, which you may or may not be able to see properly in the video, then finally the powder started looking correct. Okay, so I'm going to finish these up, but I'll only video little bits of it if I feel like it.
With the parts epoxy powdered, they're now going to be good until I get around to actually painting something for real. And the epoxy powder comes from prismatic powders. That's a lot of P's in a row, folks. But here they are. And because I was really careful with the powder thickness, I didn't want to have a great big gobby mess of powder and have to drill out the holes. Like, I actually want those holes to have some powder in them because they don't get painted. These hinges never come apart again. They're going to go together. They get painted and then installed into the car, or they could be painted in the car. I think I'll paint them separately, but I won't be taking them apart again. So I don't want them to rust, and I want them to be as corrosion proof as I can. And I think we've done about all we can to make this good. If I had the powder for the finished color of the car, I could have done that, but the shoulder bolts are, I mean, those bolt heads are going to rust and things anyway. So it didn't take too much to put them together. I was happy with the way it all went. Every once in a while, something the powder makes it a little tighter, but not too bad. And hey, this was just the best. This was so much fun to assemble these silly things. And that's how it's done, folks.
Yeah, and it works just perfectly. Now, before this is all done and installed for good, we'll get a little red Loctite on here, just sort of belt and suspenders with the Nylox, because they need to be set at a certain tension. Again, all these are ever going to do is get looser. They're never going to tighten on me, so not too worried about those. They probably should be fine, but cars vibrate a lot, so take care. And a little Loctite should fix them in place pretty much for life. So we're going to call that one a good done deal. Let's get them put on the car and see how they all work in there. Okay, and with that, they're both in and working fine. A little bit of adjustment here and there, as there always is whenever you put hinges on things, but everything was working as before, so just as smooth as silk. It's working really nicely, and then you can see here, no lateral. Trying to push that hood over and bull strong. So that's really, really good. And once again, just like before, I can put the hood wherever I want it and it'll stop. Okay, so it isn't going to come flying up and clobber my overhead, which again, once the car's on its wheels, isn't going to be a problem, but we don't want this to be a problem ever, really. Anyway, put the fender in, make sure it looks good. Got to be happy with that. Okay, so to wrap, we started off with the floppy hinges that then became more floppy the more the rust came out of them, eventually becoming basically unusable. Hinges that are no longer available are a real pain. So we drew these up in CAD. We got our friends at Send Cut Send to cut them out and bend the brackets. The bends were absolutely perfect, in case you're wondering. And now we have a fully functioning hood. The hood's carbon fiber, so this hood weighs about half of what a stock hood weighs. It's in around, I think it's 7.5 kilos. So it weighs, actually, 7.35 kilos. So it weighs almost nothing. Anyway, I'm now really happy as parts of the car are actually starting to come together for a change. So we've still got a few other projects that we've got to work our way through, and we're just cleaning up all these stupid little things that are going to slow down your build. And with that, thank you very much for tuning in. We do appreciate all the likes and subscribes. Give us a thumbs up. That's always helpful. Got to keep the algorithm happy. And until next time, keep your stick on the ice.